Wonderful. So that's all it really takes to kind of get this going. If I save it, I can then go back to here and I can apply this to my minigun. Just kind of open up the blueprint and I'm going to set this up such that it's all plugged in. So to do that, I'm going to set minigun audio, which I created earlier, to be the one that I just created called minigun audio. Now, if you want to play any of these triggers, all you need to do is get the parameter interface from the audio and then call the name of the thing you want to do when you want to do it. So what does this look like? Well, let's check it out. I'm going to hit play. Great. Cool. So we have the audio for the minigun done. Next up, let's go ahead and start looking at how we can go ahead and get some music playing out in this environment as an extension on meta sounds. Now, we can play, this is going to be called sci-fi music. Now, sci-fi music is going to be very similar in some ways to before, but also, check this out. If I was to create a square generator, you're going to hear something like this. My apologies, it's not going to sound great. Alright, very loud square wave. Not particularly wonderful to listen to, but it's the first step in making something cool, because it takes a frequency and then plays that audio. And if I wanted to, I can go ahead and I can actually look up different notes in different scales. I can then find the frequency of them and play that accordingly. So if I wanted to, check this out, I could go ahead and look up a scale. Let's get a major scale right now for the time being. And the note I play is going to be a value. Let's get a different note every time. So I'm going to get a random float. Okay, going to plug this in. Okay, so that's plugged in. I'm going to get a random float between 60 and 72. And check this. Alright, yes, that's not exactly Mozart, but it's another step closer to making something that I think is pretty cool, because we can now see that that's going to play different notes from a different scale. You know, I can even go ahead and get a minor scale and start to get this. Alright, yeah, I know, still not wonderful, but bear with me for a second, let's make this more interesting. First thing we've got to do is we need it to sound less horrible whenever a note plays. It's playing that square wave, but if we want to, we can use that same thing as we used before, the envelope, which kind of brought the sound up over time, can actually be used to bring it up and down again. So if I wanted to get an envelope that automatically goes down again, I could do that here. I'm just going to multiply them together, and all we're going to do is I'm going to say, hey, whenever you play a note, I want you to take this long to go in. Again. So if I wanted to get an envelope that automatically goes down again, I could do that here. Multiply them together, and all we're going to do is I'm going to say, hey, whenever you play a note, I want you to take this long to go in. Okay, that's kind of working. Let's get this automatically repeating and playing itself to a BPM so that I don't have to keep mashing that button. So same as before, I'm going to set up a BPM. That's kind of working. Let's get this automatically repeating and playing itself to a BPM so that I don't have to keep mashing that button. So same as before, I'm going to set up a BPM. And I might as well go ahead and make that a variable, which I'm just going to call BPM. Okay.
You probably know Vistaprint for business cards, but did you know we print everything you need to brand your business? We print banners and signs that help you stand out, and must-have merch like tote bags, t-shirts, and hoodies. If you need it, we print it. Print it all with 20% off for new customers with code NEW20 at Vistaprint.ca.
Alright, that's not great, but that's okay. Because what I'm going to do from here is I'm going to start to treat this as something that we can make a little bit more interesting. Because I can go ahead and I can look up this amount of time, and I can make this last for only that period of time. Okay? So for instance, if I wanted to, I could get this, and I could say to this, I want to send this time out as a variable that I'm going to call bar time. This is going to be how long a bar takes. And because of that, I'm going to set this division of whole note to be 1. So look up this amount of time, and I can make this last for only that period of time. Okay? So for instance, if I wanted to, I could get this, and I could say to this, I want to send this time out as a variable that I'm going to call bar time. This is going to be how long a bar takes. And because of that, I'm going to set this division of whole note to be 1, so that it takes a little bit longer between. Now over here, I can at any point receive a time, which in this case is bar time. I can plug this in to make it last for this amount of time. But I don't quite want that. I actually want to get this and make it go for a 0.33 as the attack. So it'll take 1/3 of the bar, it comes in, and for 0.66, it's going to fade out. Let's check that out. Okay, still not great, but we're on the right track here. What I'm actually going to do here as well is instead of just plugging this into here, I'm going to turn this into my own little beatbox. And that is, I'm going to send the trigger as well. And I'm going to call this bar trigger. And over here, we're going to receive bar trigger. Okay, so we're on, if I hit play, that's kind of just sending itself through. All right, cool. So the reason I did this is I'm also going to go ahead and I'm just going to duplicate it, but this time instead of having this as the bar, I will actually make one that is beat trigger. Trigger spelled correctly, and I'm going to make one called beat time. Okay. because if I wanted to, I could get these. Okay, I could get this exact same logic that we've got right now, and I could start to layer multiple effects on top of each other. Would help. Help if I plug them all in. Okay, and I'm going to multiply that. Oh, sorry, not multiply it. I'm going to mix that together. And now we're going to have one that controls sound that's playing over the course of the bar, and one that is each individual beat. So for here, I just need to set this as beat time and beat trigger. Okay. Now, another cool thing that I can do just before I completely finish this off is I can grab this and I can also send this as the current note. So now anything can look up the current note. So over here, instead of me just getting a random note to play, I actually could receive a float and find out the current note. More importantly, I could then subtract this number so that we find a note pretty close to the current note. And if I was to subtract a number between, say, 3 and 8, and highlight chord tones only, it's now going to get me a random beat note that's similar. That's kind of cool. So we've started to kind of like get this feeding into this. A little bit weird still, but that's okay, because we're starting to get something cool. And you know, I'd love it if this was actually set to say something really short, so it really came in quick, like 0.05, and it faded out, so it almost actually cut itself off. Alright, so we're starting to get something here. That's kind of cool. I want this to sound a bit more sci-fi though. So I'm also going to go ahead and I'm going to make a ladder filter. And props to Dan Reynolds for showing me this one. Ladder filter allows me to kind of set a cutoff filter so that the sounds that play through it can actually, we can change them up a bit. And it sounds a bit strange if I just hit play, but if I wanted to, I could go ahead and say, hey, every single time you go and you play an envelope for audio, I also want you to get an envelope for a float. And I want you to remap that, so to arrange. I'm just going to say 200 to 2000. Just as an example. And that is now going to control the ladder filter. So the reason I'm doing this is because if I want to, I can say every bar, I want to trigger this to play. Again. And I want this to take something pretty similar in terms of timing as this one. So I'm going to duplicate them just to make it a little bit different. I'll set this one to 0.25 and 0.75. Cool. And that's going to remap and play a ladder filter. Alright, so that's kind of cool. We're starting to get somewhere. What I'm actually going to do now, though, as a final little piece, is, and this is a little bit cheeky, is I'm going to get this and I'm going to send this value out as ladder filter. Okay? So I'm storing this, but I'm not feeding it to anything inside of this one. Okay? And the reason I'm doing this is I want you to show you something in the world with what we're creating. If I was to get this sci-fi music and just drag this into the world, and I was to hit play. So if I was to set this up, we've got the music playing, but if I ever touch these little sections, notice they flare up. So a fun little thing we can do is those pickups that we saw in the world just now, these things, we can actually have separate sounds play off of them. And you can see that I've already set up the logic to play a sound at their location. Okay? Now, the reason I've gone ahead and done this is because what if instead of triggering just the bars and the beats, we also triggered the quaver? You may know this as an eighth. Okay, so quaver. Same logic as before, except this is going to be 8. All right, so why have I done this? Well, let's go ahead, and this time I'm going to create a new meta sound, which is going to be called pickup sound. Okay, and pickup sound is actually going to be this section. Control C, except in here, this is now actually just going to receive it because sends and receives are actually global. So what this means I can do is I can actually have all the stuff as before in here to receive it, and then output it inside of a separate pickup. So it actually layers these on top of each other. I don't want these to be beat time, I want these to be quaver time. Current note is still the same, and this will now be on quaver trigger. Okay, now I'm going to quickly plug pickup sound into my pickup. So I've set up a variable for that already. Check this. So that actually added those extra notes there. But the problem is it keeps playing it, well, to infinity. So let's go ahead and look at how to finish. Note is still the same, and this will, I've set up a variable for that already. So that actually added those extra notes there. But the problem is it keeps playing it, well, to infinity. So let's go ahead and look at how to finish this off. And this part's pretty straightforward. What I need to do here is, when we play it, I'm going to actually count the number of quaver triggers that are coming through. So I'm going to count them, and I want to compare this. And I want to say to this, if this count that's come through is less than or equal to 8, then I want you to keep playing. Now, if it is not less than or equal to 8, then I want to get this and I want to delay for maybe 1 second and then finish the sound. And with that, we now have this. And that's it. We now have procedural music that's being fed information from stuff within the world. And it was honestly pretty easy to make. So I'm really excited to see where this goes. I'm really, really excited to see what folks do with this, because honestly, I can't wait to see Unreal Engine's surface materials. Conceptually, I want you to picture audio shaders. And today we're going to be going from miniguns to music. This will allow...
Imagine
the spinning up and spinning down, the starting, the stopping, and like the repeating of all of the shots through it. And I'll show you how that works now. Let's begin plugins. For this first effect, we have the spinning, we have the fire, but he made sound. So we can see that we have this barrel wind start. Good idea. Maybe not to the level that we just did. But for this, I can use what is called manage. So I'm going to get this value that's 0 to 1, and I'm going to multiply it by 2.5 so that it's from 0 to 2.5. And we're going to plug that into the pitch shift this time. Let's take a listen. Connect this at the moment. But fortunately, I can make one because I can actually go ahead and I can create inputs that trigger via a name that we've set up. So and in theory, if it's playing, I also want to stop this effect. And let's take a listen. Wonderful. So that actually goes ahead and plays that separate sound that stops the others. Now, there's one little thing that I'd like to do to get this really working the whole way through is instead of this just being on play, in the event that we haven't fully destroyed the sound and I start spinning it up again, we probably want the ability for this to actually spin up again as well. So I'm going to get my spin down trigger and up with a value that so the reason that sounds so bad right now is that every single time it's playing, it's going ahead and stopping itself the next so I'm going to say, hey, I want you to randomly play a sound, specifically fucking around each time. It's switching between different shots. That part's working. Now the next thing that I might want to 5 and cool, so that the sounds don't keep clipping again and again this time being. And I'm going to duplicate that entire setup that we have to be the one that I just created. Great. Looking at how. So we're going to mix. All right. Very loud square wave. Not particularly wonderful to listen to, but it's the first step in making something cool because it takes a frequency and then plays that audio. And if I wanted to, I can go ahead and I can actually look up different notes in different scales. I can then find the frequency of them and play that accordingly. So if I wanted to, check.
Hi, thank you all so much for coming out. I really appreciate it. My name is Patrick Hart. I am a composer and technical music designer at RA Labs. We are working on a very cool, very unannounced music creation game. Past a ton of first-person template in Unreal. So let's think about what the ball pit balls from Chuck E. Cheese. And it has this like, it's quiet right now, but it has this like insane, serious, out of place gun sound that we are definitely gonna get out of here. It's not from our game. So let's get started. This tells me is we want to make something that's like fun, is charming, it's kind of cute. And also importantly, important point, we're gonna do this without audio files. I'll get into why later, but first of all, how do we create some music in Unreal without audio files? And the first thing to do is to make a meta sound source. I'm gonna call this MSS_BGM for background music. We'll open it up. Hopefully some of y'all have seen this before, but if you haven't, there's a play, there's an output, there's an unfinished. I'm gonna delete that, we'll talk about it later. How do you make this make sound? So if I right click, I can type in and search for nodes. I'm gonna grab like a sine tone, plug in the output. We've already made some music, thank you. I appreciate it. I can change the frequency 1000. Now I can censor all of the expletives in this presentation. So how can we make it make some notes? So frequency. Working with frequency directly is a little tricky. It's if you think about a piano, if you move linearly up a piano, you're moving exponentially up in frequency. So it's hard to work with directly, but we can just grab like this MIDI to frequency node. So MIDI corresponds to notes on a piano, 60, it's middle C. I can go an octave above middle C, There it is. So let's make some different notes. Now I'm gonna do like basically the classic procedural music demo real fast. I'm gonna make a random integer node. It's gonna start at middle C, it'll go up to 2 octaves above middle C, I'll plug it in, it'll convert it to a float, and let's go. Okay, getting. Okay, getting somewhere. Let's make this a little bit nicer. And what I can do is I can plug this random float into a MIDI note quantizer. I can plug that in. The root notes, this is like what key we're in. I'll make it an input. That's 4. Foreshadowing. 0 is C. I can grab this scale. This is like, we're going to quantize it to a scale. So I pick some of the notes on the piano, and we're only going to. I just select those notes. This convenient little function that has all these scales. You can't see them probably, but there's all the good scales, including the best scale, Lydian, which is our scale for today. So now, just like a little nicer. We're getting somewhere, right? Let's shape, it also kind of sounds like computer music from the 1950s. So let's take some steps to shape the actual sound. I'm going to bring up an 80 envelope. If you've used a synthesizer before, an envelope might be familiar. Envelopes, all they do is draw a curve from 0 to 1 and back down to 0. And this is useful because if you think about a synthesizer has lots of knobs. And so what an envelope does practically is it turns the knobs for you so you don't have to turn the knobs. So I'm going to connect this to the volume. I'm going to connect my little repeat pulse to the envelope. I'll make the decay time the same time as the pulse. And now, All right, we have notes. It's like individual notes, right? But we're still very random. This is like super random, right? So I'm going to take a moment to step back to the PowerPoint and talk a little bit about randomness. Random numbers are very easy to produce on a computer. They're very, very easy. So the temptation is strong to sonify these random numbers because they'll just go on forever and you can have infinite music. But this is chaos and people don't like chaos. People want something to grab onto, right? So you have to shape the random numbers if you're going to use them. It's a powerful tool, but you have to compose the randomness. So how do you do this? If I highlight just a small fraction of the random number stream, then I can, for example, repeat it and create an interesting pattern. I can vary the length of the fragment or select a new fragment and create new patterns. And this works for sound also. The way we do it is actually by exploiting a flaw in the way that computers generate random numbers. They're not truly random, they use a starting seed, and if you have the seed, you can reproduce the stream of random numbers. So I want you to think about, as we proceed, the idea of composing randomness and what that means. It's an important part of procedural music. Okay, so we're back here, and let's do that thing that I just talked about with the pretty visuals. So I'm going to make like a little pulse section. I'm going to disconnect the trigger repeat. And what we need to do is we need to count. If we want to select a fragment, we've got to count this. So I'm going to grab the trigger counter. I'm going to count 8 note pattern, and it's going to be 8 eighth notes. The way that I know this is that I'm going to establish a clock, the BPM. For today is 140 beats. Per minute. I want to make them eighth notes, so now we know 8 eighth notes, that's going to be a bar. So what I'm going to do is I'm going to make this a variable. I'm going to call it bar. It's up there, I think. I swear. And I'm going to make this also a variable. This will be called pulse. This is a neat thing that I always wish I had in blueprints, but I don't because meta sounds are not blueprints. So now if I connect the pulse and connect the bar, bar. Cool, so we have a pattern, and if I passed out right now, it would just keep going forever. So let's make some new patterns, right? And if you recall, the way to do that is with random seeds. A new seed will produce a new set of random numbers. So if I make this a variable, and then I want to count the bars, so grab my bar. I'm going to count that. I'm going to count. 4 bars. And every time 4 bars happens, make a random integer. It's going to be a very large number, so we don't repeat seeds. And then I'm going to set my seed. Also, this is only going to start counting after the first bar, so this is a little annoying, but I'm going to also start counting when I first hit play with this trigger any. Sorry. This is a little annoying, but whatever. Okay, so. New pattern. Cool. Okay, so now what have we done? We have 4 bar segments, and they're each going to produce a new pattern. What else can we do with that? One thing that we can do is we can make a rhythmic pattern from that. Easy way to do that is to filter out some of the notes. So if I grab this filter and filter my pulse, also connected to the seed because I want it to be a pattern, and let's let like 60% of the stuff go through. Starting to make a little groove. It's a cool thing that all the random nodes in MetaSounds have these reset and seed inputs, so you can do this like kind of across the board, right? Save in case of disaster. Next thing I want to do, I want to make a counter pattern that kind of goes along with it. So I'm going to make a bass that goes along with it. When I think bass, I think saw, I think ladder filter. Everybody knows. this stuff. And I'm also going to use an 80 envelope here, and this is going to turn the knob, the volume knob, with a little multiply, and it's also going to turn the frequency knob on my filter, so it does the like classic synth bass thing. This is a frequency, and remember this is difficult to work with, but I don't want notes, so instead I'm going to use the this linear to log frequency. It lets me scale it from 0 to 1, does some logarithmic math for me, and I can just plug this audio output directly into the float. This is a nice thing from 5.5 that it'll just convert for you. And it's actually cool because the audio envelopes run at audio rate, so it like updates faster. I can grab my pulse, and let's give this like a 111. Let's give this like a decent synth bass range. Let's plug it into our output and see what we got. Cool. And the decay time is very long, so let's make it short. In fact, you know what I'm going to do? I'm going to grab this time, and this is just the time that it takes an eighth note, to the time that an eighth note takes at 140 beats a minute. So I want to make that a variable. I'm just going to start plugging it into my decay times, so everything's consistent. And I'm going to plug it in here. Now, we have a little bit of a bass. I'll make the resonance a little higher. In fact, I'm going to make the frequency higher. 555. All right. That's the bass, right? Okay, so let's make a pattern out of this as well. So we need some notes. I want to make the MIDI to frequency. I don't need like a bunch of notes like a scale. Really, what I want to do is I want to add a root note. I already have a root variable, which is 0, C. And I want to add like, I don't know, like 36 to get it just up high. High enough that we can hear it. Okay, so what I want to do also is make a little pattern, and it's going to be just like the root note and an octave above that. So I'll make another add here just to give it some pitch variation, but it doesn't need to be playing like funk or something. And I'll select, with this trigger route, either the octave above or the root. And I can choose it using this filter that we were using before. This looks familiar from a moment ago. Or the root. And I can choose it using this filter that we were using before. This looks familiar from a moment ago. I'll make it just like a 30% probability that we pick the octave above. I'll grab all these variables that I already have. Once a bar, it'll reset. The seed, it'll use my seed. I also want to use this filtered pulse. In fact, actually, well, we'll try this first. All right, so now we're getting closer to a synth bass. We got octaves. I'm gonna filter do the same thing, filter the rhythm here, like I did before. 0.6 probability. Go right in here, connect all the stuff, and now. Okay, we got another groove. Let's hear how the grooves sound together. Right in here. Oh. Let's hear how the grooves sound. Together. Okay, together. Okay. And it's very like because they're using the same pattern, it's a very modern dance. They're like super synced, which is a little weird. It's not a groove. This is not funky. This is just a little weird. So what do we need to do? We need to make a new pattern, and to make a new pattern, we just need a new seed. And to make a new seed, we can just add 1. It's that easy. And it'll be a brand new seed, a brand new set of random numbers. And now they're playing different stuff, which feels a little bit more interesting. Cool. Getting somewhere. Okay, so the next thing, we have this mono mixer, which is gross because, as you can see, we have 2 speakers at either side of the auditorium. So I'm gonna make this a stereo meta sound in this panel here. I can grab stereo and boom. We have 2 outputs. Easy as that. The bass can be mono. Actually, wait, I need a mixer. It's going to be a stereo mixer, 3 foreshadowing. The bass can be mono because it's a bass. It's, how that works. But this guy, I want to have a little bit of, some stereo presence. So an easy way to get a subtle amount of stereo presence is I'm just going to make a new sine wave, and I'm going to plug them both into my mixer. And for the frequency, I'm just going to multiply this by 1.00095. No, it's keyboard, I'm not used to it. 1.005, that'll work, and I'm if you can hear that. There's a subtle amount of widening happening. But let's try to do something a little bit more dramatic. I'm going to use these modulation inputs on the sine because they're kind of fun to play with. And what I'm going to do with this, I'm just going to drag my bass and make that a variable called bass. And it's pretty neat. You can make audio variables, all this stuff, and route them all around. And I'm going to plug this in. If I plug it in directly, you're not going to hear that much. What I want to do is multiply it by a float. I'm going to multiply it by a big float, 1,000. This is like a do not plug this into your speaker situation, but you can plug it into the mod input. And now over there, right? It is doing some weird stuff. If I want to be different over here, I can just run this into like a delay. I can make the delay conveniently an eighth note because I already have it. Feedback is 0. So now we have a little bit of, stereo stuff happening, which is cool because we're humans with 2 ears for the most part, and this is nice. So, okay, I'm gonna make this like for the most part, and this is nice. So, okay, I'm gonna make this. Like a little bit less crazy, like 200. And Now it's just like a little bit more fun. Okay, so we have this stereo mix of three. I promised you I was going to use it. I'm going to make the world's fastest kick drum, and I'll also show you how nifty submix or subpatching is in meta sounds. I'm going to make a new meta sound called MSS kick. I'm going to open it up. I need an 80 envelope. I need a sine wave. I'm going to use the envelope for volume. We're turning the volume knob. We are connecting the unfinished, which I'm still going to talk about later, but I'm going to use it. We're going to use this for the frequency also, linear to log frequency, and plug this right in, connect the trigger, and let's see how it sounds. Okay. It's a laser beam, it's not a kick drum, but I swear, we're actually pretty close to being a kick drum. Let's make the decay time a little bit more reasonable, the curve, the frequency. I'm going to actually make this one is going to only respond to the first half of the curve. It's kind of like making a faster envelope for free. And now, it's a little quiet, but it's a kick drum. Sounds like a kick drum. I'm going to even plug it into a wave shaper because that makes everything sound better. There, it is the world's fastest kick drum, not the world's best kick drum, but it is a kick drum. And now, the neat thing is that I can just go back to my music, type in kick, and there it is. I can but it's a kick drum. Sounds like a kick drum. I'm going to even plug it into a wave shape to my output. Plug it into my output. I can grab the pulse. There's a lot of kicks. I'm going to, it's also clipping like mad, so I'm gonna like make this, I'll make the kick a little louder, and I'm going to play less kicks by just describing a sequence, which will go through these. I'm just gonna play every other kick. Okay, so for now, we have a little bit of background music. And this is cool, except we're just in Metasounds. Let's bring this into our game. So what I want to do is make a blueprint that is going to control all of our music logic. Because I'm not just going to use this one meta sound, I'm going to use a bunch of meta sounds. I'm going to make BP_music manager. It's going to manage the music. You can do this on like the game instance if you want to bring it between levels, but I just want to have one actor in the level. It'll work for now. So let's go into our event graph. The first thing I want to do is I want to make a clock, because I'm going to have a bunch of stuff. The music. You can do this on like the game instance if you want to bring it between levels, but I just want to have one actor in the level. It'll work for now. So let's go into our event graph. The first thing I want to do is I want to make a clock, because I'm going to have a bunch of stuff from different meta sounds, and I want them all to be in time. So I'm going to do that with quartz. So the first thing I want to do, and this is a little bit of a boilerplate section of the presentation, I apologize, is I want to create a clock from my quartz system, a new clock. I want to give my clock a name. It's going to be Clocky. I'm going to make it a variable. It's also going to be called Clocky, our friend Clocky. Clocky needs a BPM, set beats per minute. The BPM for today is 140 beats a minute, and I need to create a sound 2D. Not 3D, 2D is going to be our BGM that we just made. I want to make this a variable because I want to do stuff to it later. It'll be called BGM. And then I want to play it quantized. Our BGM that we just made. I want to make this a variable because I want to do stuff to it later. It'll be called BGM. And then I want to play it quantized. This is the secret sauce of chords. I got two references. And this is, now it is really boilerplate, I apologize. I need a reference. I need a boundary. This is like, how quantized is it? I'm going to make it bar, I'm going to make it bar relative. The next bar is when this is going to start. But when does the clock start? And I need to create, actually I'm going to make a custom event. Doesn't need a name, I don't care. I need to switch. Boilerplate, I'm sorry. And queued, this is finally, we're nearly, doesn't need a name, I don't care. I need to switch. Boilerplate, I'm sorry. And queued, this is finally, we're nearly there. I'm gonna start the clock. So what did we just do here? I created a sound. I played it quantized. It's going to play on the next bar. When it's ready to play, when it's queued, we're starting the clock. It's all going to start together. It's going to be beautiful, I promise. Let's try it. Boom. So we're in the game, moving around. It's all going to start together. It's going to be beautiful, I promise. Let's try it. Boom. So we're in the game, moving around. Bam, bam, bam. Cool, and we got all that stuff. So, okay, now that we have a clock going, let's add something interactive, some interactive sound. And so I'm going to make a new meta sound, a quick meta sound. It's going to be called MSS_moving. So what I want to do is when we start moving, it's going to start playing a little sound effect, and when we stop, it'll stop. And start, it'll start again, and so forth. I'm going to make a little sound effect that's kind of like a little footsteppy sort of thing. So I want some white noise, and I want an AD envelope, and I want to multiply, control the volume. I do not need a one shot. Let me the decay time. Control the volume. I do not need a one shot. I'll make the decay time super fast, like 0.02. And I need a trigger repeat. To set a little internal clock. If you recall, the BPM for today is 140 beats a minute. And we're gonna make it 16th notes. So I'm gonna trigger this envelope on 16th notes, see what it sounds like. It's vaguely footsteppy. It is a very boring sound. So let's spruce it up a little bit. Remember, we're trying to be cute, playful, fun. There's nothing more cute than a bit crusher. I am not even kidding. The bit depth, it'll be a little crunchy for sample rate. This is a frequency. So we're gonna make a linear to log frequency. This is gonna be random, a random float. In a slightly, I don't know, 220 to 12.222. Should always just repeat numbers when making numbers that don't matter that much. This is going to be the pulse. So we're gonna make a new random number every time. We pulse. I also want to make a pattern, so I'm going to count these pulses. Counter. And on reset, I will reset the random float. How many times do we want it? We can make this random too. So it'll be patterns of length from 5 to, let's say, 12. And it'll be a different pattern every time we start it. It's kind of fun. So let's hook this up. And this is very easy. Over here, I'm gonna make a custom event. It's gonna be called moving. And I will create a sound, 2D, and wait, I don't wanna do that. I don't wanna do that. First of all, we need to find out where how to get a hook, a gameplay hook, for when the character is moving and not moving. So actually, let's start there first. I'm gonna open up the first person character. You've seen this before. It has, look at this, input action move. If I expand it, I have started, I have completed, that's all we need. I don't wanna put stuff in here because I want to keep things in my music manager. For right now, what I'm gonna do is I'm just going to enable input on this blueprint and get the player controller. You could also just like send an event dispatcher or something like that, but I don't know. We can just also get that, what's it called, IA move, and just use that right here. So when we start, I'm going to create a sound. Every time we start moving, we're going to create a new moving, doesn't have a J in it, moving sound, and I'm going to play it quantized with chords. So I need my clocky, and doesn't have a J in it, moving sound, and I'm going to play it quantized with chords. So I need my clocky, and I need to make a quantization boundary. It's a little different this time because I want it to kind of start right away, but I want it to be quantized. So I'm going to make it a 16th note, the next 16th note. I'm making it current time relative. So this from right now, from the time that this input action event fires, it will play it on the next 16th note. So it'll play it quantized, but kind of like right away. And then when it stops, we'll just stop. That's fine. Completed. Stop, and let's try it out. Okay. So a neat thing that I want to point out here is that we have two clocks going on. Thank you. We have two clocks going on here. We have the quartz clock, and we have these trigger repeats that are in all these meta sounds. And a cool thing about meta sounds being sample accurate and quartz being sample accurate is they can just go together. I could run all day, and it would still be like totally in sync with the quartz clock, which is pretty cool. Okay. It's time to deal with the gun. The gun is ridiculous. It's silly. It's from a totally different game. We're not in World War II. We're in this cute level. So we need something more whimsical. First, I need to find and destroy that sound. So a nice way to find sound, you can filter for things like sound waves. And what's in this project? Oh, look. There it is. Okay, and a nice general UE tip. If you're looking for where things are referenced in your game, you can use the reference viewer, which is very convenient. Here's our thing. Look, it's referenced by BP weapon component. If I browse to this asset, let's see. IA shoot. First person projectile spawn. Play sound at location. No, we're not gonna do that. Okay, so we gotta put something here. Let's go back to our music manager. Remember, I don't wanna put it in there directly. I wanna go here into our music manager. I'm gonna make a custom event called shoot. And how now do I call this from the, what's this, BP weapon component? So I go back to our little reference viewer. Where does this go? Pickup rifle references it, and this is referenced by the map. That's great. That'll be easy. We can open up the pickup rifle. Look at there it is. Add BP weapon component. So now what I can do here, I can just make a variable, music manager, type music manager, and I'll make it public. I'll make it expose on spawn. I'll compile it, And in pickup rifle, compile it. In pickup rifle, there it is. That was weird. I will promote it to variable. I'll make that public too. I'll compile it. And then in the map, this is our little mesh here. Look at that, music manager, connected it. Our chain of references is complete. This is like some funky rigmarole, but you know, once you got it, now I can do stuff in here like grab the music manager and call the function shoot every time we play. And now I can do something that's not just play the bomb sound or whatever. So, okay, so I wanna, another thing that I wanna do, okay, well first, what are we gonna do with the shooting? The shooting has to be cute. If we could just take the gun out, you don't have to use guns in games, but we're doing it, so it's ball pit balls, I'll let it slide. But let's make it fun and cute and charming. So I want to make it play some notes. I want the notes to be in sync with the music, and I want them to be in time with the music. So one thing I could do is go to this shoot thing and just play some notes that are quantized. But then it's like you shoot and it shoots and then the sound plays quantized, and that's not cool. And what I can actually do in Quartz is actually like have the gunshots like happen quantized, which is kind of great. So the way that I do that, let's get our friend Clocky over here, and I'm going to subscribe to a quantization event. The quantization event is going to be a 16th note, and when the 16th note happens, I'm going to fire an event, a matching event, and this event happens every 16th note. So I'm going to call it 16th. I thought that's a good name. And so now what I want to do is I want to fire the projectile, shoot the sound only on 16th notes. So I want to create like a little gate here to let this pass when we've pressed the button. So I'll make a branch. I'll connect to the true here. I'll disconnect this guy and promote this to variable. This will be is shoot. Make this false because when we pick it up, we don't want it to play right away. So now over here on my input action, I can just do set is shoot to true when we start pressing it. I can set it to false when we stop pressing it. And we see this comment that someone has left us, which is this input action has the press trigger, so it only fires ones. And I actually have to deal with this. So I'm going to open this up, grab the trigger, it says pressed, not anymore. And close that up, don't need that anymore either. Okay, so now let's check out and see how we're doing here. Oh, wait a minute, it doesn't make any sound. Okay, now is when I confess that I've cheated a little bit. I've made a couple of sounds in advance, but I swear, I just copy pasted some stuff. This is like, you see this, envelopes, squares, media frequency, we've done this before. I just wanted to save a little time. This is the noise stuff from the footsteps. Two things I will note about this, there are two inputs, the note input and the root input. So what I need to do, well, eventually what I need to do is set these, but for right now, let's just create a sound 2D. It's gonna be called shoot. I apologize for making this in advance. And we're gonna play it quantized. So remember, the shots are happening quantized, but that is actually still on the game thread. So if you play it with the 16th note, it's not going to sound totally quantized, but I will get visually the closest frame to the actual quantization boundary. But remember, sound is like 48,000 times a second by default, and your frame rate is like, I don't know, 300 frames a second if you're really cool, or 60 frames a second or whatever. So it's not, you still have to like use quartz to get the exact frame, the sample accurate sound. So my quantization is going to be the next 16th note, current time relative. Let's check this out. Cool, okay, so that's cool. Let's make it make some different notes. And what I want to do here is, this is kind of like fun. We're going to create a fun vibe. It's going to be like a little roller coaster. It's going to go up, it's going to go down. When it hits a high pitch, it's going to turn back around and go back down. So what I need to do first, boilerplate a little bit, is I need to set my note and my, what am I doing? Set float parameters. We're going to set the root, and we're going to set, hello, the note. I got to connect all this stuff, targets, wires, cables, and the root is going to be, I don't have a variable. It's going to be a variable because I'm going to use it for the background music too. The note, well, I'll also make this a variable. I'll call it shoot note. And so I am going to set the shoot note at the beginning of my event. The shoot note is going to be equal to the sum of the shoot note, whatever it was before, plus I'm going to add a little bit if it's going up, or subtract a little bit if it's going down. So that I will also make a variable. It'll be called shoot interval. And I'll set the shoot interval at the end of this little chain. The way that I'll do that is I'll make a branch. And if the shoot note is greater than, what's a high note? 84. It will set the shoot interval to -2. So it starts going back down. So when we loop back around, it'll add -2. And then I'm going to make another branch. And if the shoot note is less than a low note, like 54, I will set the shoot interval to +2. I want to compile this and give it some default values like middle C and 2 for now, so we can hear it. Let's check it out. Cool. Another thing I'll note is that I do have this MIDI note quantizer in here, so it's getting quantized to our favorite scale of the day, Lydian. But I don't have to actually worry about that in the music manager, which is cool. One other thing I want to do real quick is it kind of like you're on the same roller coaster. If you stop, you're like freeze the roller coaster. So I'm going to start, I'm going to make it have a new note every time we start this. So all I got to do is just set shoot note. It's kind of neat. You can just set your music logic all over the place. And this is just going to be a random float in range. Can be just whatever our range was, 54 to 84, I think. And hit play. And now, it's a little more like herky-jerky. I think it matches the footsteps a little bit. Okay, cool. Now, we have done a bunch of stuff. So I want to talk a little bit briefly. You forgot that I had a slideshow, but I still have a slideshow. I want to talk briefly about why are we doing this? And so I want to talk about possibility. A big reason to compose with procedural techniques, and this is a reminder, we're composing music right now, is to create a sense of possibility that you really can't get otherwise. And this is back to my important point from the beginning. We're not using any audio files right now. And this is because audio files kind of take away some possibility. They can. If you're in a DAW and you write a song and you export it to an MP3, it might be the most beautiful MP3 that you've ever heard. But there's no possibility in that MP3. It's like, it doesn't do anything different. It just is the same every time. If I walk over here, it does not change. And so there's no possibility in that. What you want to create is a possibility space. David Kanega, who made some amazing games like Proteus and Panoramical, describes this as the possibility space. I love this term for procedural music because I feel like the best procedural music makes you feel like you're exploring this three-dimensional space. It's like this room. It's like I can't go outside of this room infinitely in any direction in this randomness, but I can explore every corner and I can see what the system sounds like in every space. So an idea I want to give you now, this is an important idea, just want to pause. I can explore room. It's like a music space. I love this term for procedural. And Panoramical describes this as the possibility space. I love this term, explore, and it sounds like in every space. Pausing is the idea that you can get possibility from granularity. What I mean by this is if individual notes are your building blocks, if you're using like this is a C, now it's a D, whatever it is, then the possibility space you can create is much larger than if you just have like a track or layers of tracks, stems, whatever it is. So if I go back to the thing, I want to show you what I mean a little bit here. I'm going to open up our first-person character. We've all been here before, as I mentioned. So I'm going to right-click and type event. If you're a composer who can get inside a game engine and look at this stuff, you can see all these hooks, all these gameplay hooks, on become view target, on end view target, on jumped, on walking off ledge, classic, hit, point damage, radial damage, end play, landed, launched, crouch, start crouch. And okay, if you are in a DAW and composing, you might be like, I'm gonna make some crouched music. This is gonna come in when we crouch, it's gonna stop when we crouch. But what if you wanna make crouched music after you've launched? And maybe you've taken some radial damage and you have not yet walked off a ledge in this thing. So how do you account for all that stuff? Maybe you want to change keys also, and it becomes this like giant combinatorial problem. If you'll forgive me, it's like you're compiling all the shaders of your entire possibility space. And the cool thing about composing with, by building a procedural system is that it's responsive because it works from granular small building blocks. So you can feed it these triggers, variables, all of this rich data, and it can very subtly shape the music that it's making, much more so than if you're using like little layers or loops and stuff like that. So I'm going to circle back to that if we have time at the end, but real fast, let's just try this again and see where we're at. So I got the gun, I pick up the gun and nothing happens. So what I'm going to do real fast, because that kind of bothers me, is I'm going to make the world's fastest pickup effects sound. I'm going to make a meta sound source. It's going to be called MSS pickup. It's going to be very fast. I'm going to make an AD envelope. It's going to be a float. I'm going to map the range from 0 to 1. It's going to be 16 to 1. I am going to convert the float to an integer. If anybody knows what I'm doing, shout it out. I'm going to convert it back to a float. What is he doing? I'm going to plug it into a sign. I'm going to plug the sign into the output. The done onto the unfinished. I'm going to hit play. Who knows what's going to happen? Nothing, because I need to multiply it by some kind of reasonable frequency. Let's make it 111. Here we go. Anybody? Harmonic series? All right, cool. Harmonic series. So let's play this real fast. Sorry, thank you for indulging me. I'm going to add a custom event. It's going to be called pickup. I can call it from this weapon component because I already have a reference. At the end here, I can grab my, oh, it's right here. I can call pick up, hit play when we pick up our thing, and I'm just going to create this sound. It's a two-dimensional sound. It's called pickup, And I don't even need to quantize it. I can just play it. Now, when we hit play, now you know we have a cute gun. Okay. Okay, cool. You notice I put these platforms over here before. This is my other little cheating addition. Let's do something with the platforms. I think I have time for this. What I want to do, I want to make the platforms like a little bit magical and fun and whimsical. And when we land on them, I'm going to play a chord. I'm going to change the key because we put the root inputs in all these things. And yeah, I want it to feel satisfying, a little spooky, you know, kind of a fun vibe. So again, I apologize. I've cheated a little bit. I've made a synth. It's just the bass, but with a higher note. And I copied it over, and there's two. Saving like 3 minutes here. One thing I want to do though is, it's not very magical, but you know what is magical? Delay. Delay is magical. And I could put a stereo delay in here right now. There is one in MetaSounds, but the problem is I want to play individual notes from MetaSounds. I'm gonna play 6 notes. If I play 6 notes with stereo delays, they'll all have it'd be 6 stereo delays playing. That's like not what you would do normally. If I was in a DAW, I would put it to a bus. I'd have 1 stereo delay. That's what we're gonna do. I'm gonna do that with a submix. So I'm gonna make a new submix, a new sound submix. It's gonna be called Delay Submix. I'm gonna go to it and open it up. I'm gonna make a new submix effect chain. A new submix effect preset. This is a little boilerplate too, I apologize. It's gonna be a stereo delay preset. I'm gonna open that up. I'm gonna give it some cool settings. Like, I don't know, it's normal settings, 0.6, a little bit of spatialization, that's fine. We'll give it a filter, put the filter on. And so now, a neat thing about this, now that I've set this up and it's going through the submix, I can just play it and hear it with a delay, which is pretty cool. So let's play some of these from our blueprint. Where am I? Music manager. Okay, so I'm gonna make an event. It's gonna be a custom event called platform. I'm also, you know what, I'm just gonna enter keyboard. I'm gonna make a little test event just for when I press enter so we can see it quickly. So what I wanna do is, first of all, I want to set my root. This is like the chord, right? So when it's 0, it's C. When it's 3, it's E flat, whatever. And so I want to set the root. The root is going to be the sum of whatever the root was before, plus I'm going to either add a perfect fourth or a minor seventh, or go down a second, if that's, you know, how you think about it. And I'm just gonna do this randomly. Float, if it's greater than 50%. 50-50 chance that we change. This is a way, I kinda like, this is like super simple, but I kinda like this idea of procedurally changing chord progressions this way. Kinda fun. One thing I do wanna do is I wanna make the root between 0 and 11. So it's like, we select the keys on a piano. Piano is, you know, A through G or whatever. And so I wanna loop this back around. I'm gonna do this with a modulo, I don't actually know, node. So if I make this 12, this is super handy for music. Then it'll count 0, 1, 2, 3, 7, so 9, 10, 11, 0. It starts back from 0 again. So this way I can just keep adding forever, but it'll always stay from 0 to 11, which is great for me. Next thing I want to do, I want to define a range for the chord. So I'm going to grab a random float in range. It's going to be from, this is my low note, so this will be like, I don't know, 40 to 50. Doesn't really matter. I'm going to promote it to variable, and it's going to be called the low range. I'm going to do the same thing for the high range, except it's going to be higher because it's the high range. I'll make it like 60 to 84. I'm going to set that to variable. It's going to be the high range. So now I have the root, I have the range of the notes, so it's time to create some notes. I'm going to make a for loop. I'm going to make 6 notes, 0 to 5. Now I need to do a little bit of boilerplate. Create sound. Sound 2D. My note is called, I think it's called saw synth. And I need to set the root, set a float parameter, call the root, which we have already set just before. I'm going to grab my variable, and I'm going to set the note parameter, in which I will provide the note. And then, lastly, I need to play it quantized with quartz, with our good friend Glocky. And I need to make a quartz quantization boundary. It's going to be based on 16ths and current time relative. And now I'm going to do something slightly fun. I'm going to make the note, we're quantizing the notes to the Lydian scale inside the metasound. So I want to spread it out among the range. And I have this index, which is from 0 to 5. And I am going to map that from the low range to the high range.